Hello and welcome. In this video, we are going to build an LR circuit, and that is going to be a low-pass filter. So let's right-click, place component, and in here we want to get out our voltage source, and we want that to be VRMS source. We can place that in our circuit here. And then we want a ground, so we'll grab out our ground as well and place that down right below that. After that, we want a resistor and an inductor, so we can drop down the groups tab here and go to basic. And in our resistors group here, we can grab out one resistor, and we'll Control R to rotate that sideways so that we have it as our output. And then we will grab our inductor over here. And any inductor will do here. Place that in because we can always change the value of it. Let's exit that. So from here, we want to connect these up in series. We'll place the voltage line into our inductor into our resistor, and our resistor leading all the way back to our negative terminal and ground. And so now that is our series RL circuit, and we do expect the current to flow up through this inductor and then down through this resistor and then back around. And remember, in series we have KVL, Kirchhoff's voltage law, and that says that the voltage that we send in will be distributed among both of these two components. So let's decrease our voltage down here. Double click on our source voltage and we'll put it down to 10 volt. Well, okay, that 10 volt, 60 hertz. We've got 1 millihenry inductor and 1,000 ohm resistor. So let's measure across our resistor with our multimeter. The multimeter can be found on the top right, or you can go to Simulate, Instruments, Multimeter. And that measures in VRMS. So the 10 VRMS that we see here is going to be seen on our meter here as well, because the meter reads in VRMS. So for our meter, we want to measure across our resistor. That can be at the very top here and the very bottom of our resistor line. When we double click on this, we want to switch it to AC voltage. It's going to allow us to measure that VRMS over time voltage. And when we hit play on that, we see that the voltage drop here drops nothing across the inductor, right? The inductor is such a small resistance right now because of our frequency that all the voltage gets dropped across the resistor. It's almost like this inductor is acting like a short circuit, right? So it likes low frequencies. So let's stop the circuit and let's increase it up to, say, 1,000. Okay that, and we'll hit play on that. We still see 10 volts, right? It still likes this low frequency. 1,000 is still considered to be a lower frequency for this inductor here. So let's increase it up to 10,000. We'll double click and we'll say 10K. And okay that, and then we'll hit play. Now we're losing voltage, right? That means that this inductor is now responding to the 10,000 kilohertz that we put into it, or the 10 kilohertz that we put into it. And that means that it's now seeing KVL. Now voltage is being dropped across this inductor and the voltage is being dropped across the resistor, and that means that the resistor is having less voltage across it. So let's increase it again. Let's go up to 100,000. We'll add another 0 in here and okay that and hit play. Right? Now this inductor is consuming even more voltage from our resistor, right? KVL says that the voltage drop across the inductor plus the voltage drop across the resistor is going to equal 10 volts. So if we only see 8.46 volts across this resistor, that means that inductor has whatever's left over, right? So we can calculate that out. 10 minus 8.46 is going to give us the voltage drop across that inductor. And so if we continue on, we can double the frequency here. We can say that it's 200,000. Okay that, and play. And we see that this inductor continues to consume voltage, right? It really responds to higher frequencies, meaning that it's stopping higher frequencies from being able to pass through it. And that's what we expect inductors to do. So as the frequency comes through here, this inductor stops it right here, and whatever can make it through gets dropped across the resistor. But whatever cannot make it through, any higher frequency responses, will get stopped across that inductor. And if we were to flip these two components here, we would see the opposite. Right, we would have a high-pass filter instead of a low-pass filter like this one. And remember that these are filters, right? So we are going to use these to filter out signals. And sometimes that's an audio signal, so we can place another circuit here that leads out to a speaker of some sort. And if we don't want the higher frequencies to come through, like a high-pitched squeal, we can put this circuit right before that speaker. Right? And then this would be some kind of input, like a voice microphone or something like that, where our voices are actually in the lower frequency ranges most times. And so the 200 kilohertz would be a high-pitched squeal or something that is being fed back through our filter systems. And so that would be something we would want to filter off, and this circuit would be able to do that. All right, let us know if you have any other questions.